In this video, we're going to go ahead and look at this problem. So we have a certain volleyball player who serves aces 22% of the time. She wants to improve the amount of time she serves aces, so she begins a new training program to help her improve her serves. On her next 48 serves, 25% of them are aces, and she wonders if the training program was effective or if it was just random chance that the percentage went up, and why. So to begin with, so she serves aces 22% of the time, but she wants that number to go up. So she starts training and starts practicing, and then on 48 of her serves, 25% of them are aces. So that went up. So she wants to know, could this be that she's improving, that the amount of serves that are aces is going up, or could it just be the random chance that it went up? So we'll go ahead and solve this problem, and we'll look at it. We'll look at our flowchart. So the first question, is it a means or proportions problem? So in this case, you have percentages. That means it's proportions because we're looking at the portion. So we follow this line of proportions. So our first step is to calculate the mean and standard deviation. And we're going to use these equations to do so. So the mean of our sampling distribution of proportions equals our population proportion, which is the amount of aces that she serves, which is 22%. And remember, you're going to want to express these as decimals because it'll help you with your calculations. So there's our sampling distribution of means. And so the next is to calculate out our standard deviation of proportion, of the sampling distribution of proportions. So we have our standard deviation of proportions, and that is the square root of p times 1 minus p, all divided by n. Now p, as we already found, is 0.22. So we'll plug that in. So 0.22 times 1 minus 0.22. And we're going to divide it by n. N is the amount of times she served, which is 48. So we put 48 down here. And now we're going to go ahead and plug all that into a calculator. So we have second square root. And I'm going to put it in as a fraction. So alpha y equals, put it as a fraction. So it is 0.22 times 1 minus 0.22 divided by n, which is 48. And so that gives us a standard deviation of 0.0598. So there's our standard deviation. We have our mean of our sampling distribution, our standard deviation of our sampling distribution. Remember, the mean is what are we centered around, and standard deviation is how wide it is. So we go back to our flowchart, follow the arrow down, and now we have to check the large counts condition. So the first step, we're going to do n times p has to be greater than or equal to 10, and n times 1 minus p also has to be greater than or equal to 10. So our n is still 48, so we plug that in. And our p is 0.22. Want that to be greater than or equal to 10, and then 48 times 1 minus 0.22 has to be greater than or equal to 10. So we go ahead and put this in the calculator. So 48 times 0.22. So that's 10.56, which is greater than or equal to 10, so we satisfy that condition. So we have 48 times 1 minus 0.22, which is 37.44, which is greater than or equal to 10, which satisfies the large counts condition. So both of these are true, and with proportions, you do need both these conditions to be true for it to work. So n times p has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. So this is true. So now we can calculate the probability using the normal CDF. And so if we go ahead and draw our normal curve, because this is approximately normal, because the large counts condition was satisfied, we find it centered on our mean, which is 0.22, And the width is determined by our standard deviation. Now here, she went and on these 48 serves, 25% of them were aces, which is up over here. So this is 0.25. So we want to know this area because we want to know, is she improving? Is she getting better with her serves? Are they more likely to be aces now? And so we're going to do that by finding the probability that will get a sample greater than or equal to 0.25. And we're going to calculate that out with our normal CDF. So we go second distribution, normal CDF. Now in this case, we want everything bigger than 0.25. So the smallest number we want is 0.25. The biggest number, some big number, because we want to go off to infinity. Again, the calculator can't handle infinity, so we just put a big number in there. Our mean is what are we centered on, which is 0.22. The standard deviation, our width, is 0.0598. So we go ahead and hit enter and put that in. So we get our probability, which is 0.3, I'm going to put 310. So that's 31%. So there's a 31% chance that her program didn't help her, that this is just random. This is just a random increase. So for this, again, the question that we're wanting to ask, was the training program effective or was it just random chance that her percentage went up? And why did that happen? So in this case, I would say no. The program appears to not be effective because the probability that it was not effective was 31%, which is high. So this appears that this improvement that we had, this 30% increase, could just be attributed to random chance and random variation in our sampling distribution, and not through actual improvement.